The slotted arm AB drives pin C through the spiral groove described by the equation R equals 1.5 theta. So R is a function of theta. If the arm starts from rest when theta is 60 degrees and driven at an angular velocity of theta dot equals 4t. So theta dot is a function of time. Determine the radial and transverse components of the velocity and acceleration of the pin when t equals 1 second. So we need to find the velocity and acceleration, which means we have to solve for these 5 variables so we can find the velocity components and the acceleration components. And since theta dot is given as a function of time, let's start with theta dot, which is 4t. And if we take the derivative, it becomes a constant as theta double dot equals 4. And r is equal 1.5 theta. So r dot becomes 1.5 theta dot, or 1.5 times 4t, which is the definition of theta dot. And this becomes 6t. And if we take the derivative one more time, we will get 1.5 theta double dot, or 1.5 times 4, which is 6 meters per second square. Again, the question is asking for the velocity and the acceleration when t is equal to 1 second. So let's see what we've got so far. We found theta double dot, which is a constant, equals to 4. We found also theta dot, which is 4t. So at t equals 1, this becomes also 4. We found r double dot, which is constant. We found also r dot, which is a function of time. So it's equal to 6 times 1. But r is still missing because it's a function of theta, not a function of time. Remember again, the question is asking for the velocity and acceleration when t is equal to 1 second. So to find the value of r when t is equal to 1 second, we need to find theta when t is equal to 1 second. Or mathematically, we need to find theta when t is equal to 1, and we have theta when t equals 0, which is 60 degrees. So basically we have an initial condition of t and theta, and this is where we take advantage of the definition of theta dot, because it is d theta over dt, and we can take dt to the other side and integrate both sides to take advantage of the initial condition. And by doing that, the only unknown in this integration will be theta when t is equal to 1, and by solving, we will get theta as 3.05 radians. And now that we found theta at t equals 1, we can solve for r, which is 1.5 theta, which is 4.57 meters. And the rest is straightforward. You just need to substitute the values in VR, v theta, AR, and A theta to find the unknown components.